Hello there and welcome to Lower 6 Further Maths A-Level Pure Core 1 past paper, June 2011. We're looking at question 5 here. The curve shown in the diagram is y equals x square root 1 minus x squared. Write down the value of a. Now a is a solution for the x-axis, and when we're finding solutions on the x-axis we set the y component equal to 0. So we're going to start off with the equation 0, replacing this y here, equals x times 1 minus x squared. So what we've got here, two expressions, x and square root of 1 minus x squared, times in together to make a 0. Now either one of those expressions is going to equal 0. The x solution equals 0 at that point there. We don't want to find that point there, we want to find the point over here. So I think what we can do here is divide by x. We know x is 0, so we've taken that into account, and we'll set 0 equal to the square root of 1 minus x squared. Square both sides, you get 1 minus x squared, and factorise into two brackets. We get two solutions here. One solution is going to be x equals minus 1. That's not very useful to us because our graph looks like it's only got positive x values, or x is going to equal 1, which is our value for a. So a equals 1. Great. So what we're going to then do for part B, let's have a read. The finite shaded region bounded by the curve and the x-axis is rotated through 360 degrees about the x-axis. Find the exact volume of the solid generated. So pull out our formula for volumes of solids generated, and we get pi times the integral between our boundary of y squared dx. Now what we're referring to y here, we're referring to y as in the equation, y equals x times 1 minus x squared all square rooted. So we can rewrite this as pi times the integral between the boundary of, we're going to square our function as well, so it's going to be x squared, and then it's going to be square root of 1 minus x squared squared, and that will undo the square root symbol, so it will just be 1 minus x squared dx. So carrying this on to the top, if we expand the brackets now, we get pi times the integral from 1 to 0 of x squared minus x to the 4 dx. We can now integrate these. Pi times, okay, so square brackets coming in now. The integral of x squared is x cubed over 3. The integral of x to the 4 is x to the 5 over 5 between 1 and 0. And using our calculator, we can actually do most of this using the integral button on our calculator. So if you look to the top of your calculator in the normal calculator mode, you'll see an integral symbol between two boundaries, and that's where you insert your function. So press that button and this will come up on your display. What you then need to do is, using the up, down, left and right buttons, is navigate the cursor into the correct positions and type in what we have at this stage here. Integral between 1 and 0 of x squared minus x to the 4. You need to use this x button that's on the right hand side of the button you've just pushed. Just like this. 1, 0, x squared minus x to the 4, and then press enter on that, and you get 2 over 15. You would have got exactly the same thing if you would have just done it manually, plugging in 1 into your function and then taking away 0 into your function. It's effectively the same as 1/3 take away 1/5 is 2/15. So the answer here is 2/15 times pi. And that's the volume for the solid generated rotating 360 degrees around the x-axis. 6 marks in total for that question.